Today we are going to talk about the iron sulfur proteins. So these are useful in the electron transfer, and these are non-heme proteins. Okay, so there are two different types of iron sulfur protein. The first one is ferredoxins. Next, ferredoxins. Okay, so first we'll go for the ferredoxins. So in the ferredoxin, iron is the central metal atom. So this is attached to the 4 sulfurs, which further attached to cysteine unit. Okay, so this iron here having two different oxidation state. In oxidized form, it is having iron in a +3 oxidation state. In reduced form, it's having iron in +2 oxidation state. Okay, so we know that sulfur is a Libel ligand, so it will be high spin. So in +3 oxidation state, iron is having this kind of configuration D5, 1 2 3 4 5, whereas in +2 it is having a 1 2 3 4 5 6. Okay, so both are paramagnetic. In both these states, paramagnetic. In oxidized form as well as in reduced form, ferredoxin is a paramagnetic in nature because unpaired electrons are there, and both are EPR active. Okay, so now if you see the mass bar spectra for these two complexes, so we know that this is the distorted tetrahedral shape, having a distorted tetrahedral shape. So in this case, electric field gradient, in this case electric field gradient is symmetric, whereas here it's not a symmetric, but the shape is a distorted tetrahedral. So we'll get a two peaks, one with the less EQ, another one will be with the more EQ. So this is for the oxidized form and this is for the reduced form. Okay, so this is about the ferredoxins. So ferredoxins are not that important, but ferredoxins are very important. And so there are three types of ferredoxins we have. So one is 2Fe, 2 sulfur. Second, 4Fe, 4 sulfur. Third, 3Fe, 4 sulfur. So first we'll see the 2Fe, 2 sulfur. Here, 2 iron atoms are here, which is attached to 2 sulfur units, and further, so this is 2Fe, 4S system, SS. These two only. So this is attached to cysteine. So here it's very important, we need to remember that two bridging sulfurs are present in 2Fe, 2 sulfur unit, and each iron atom attached to 2 Libel cysteine. So this is Libel sulfur, this is the bridging sulfur. Okay, so in oxidized form and reduced form. In oxidized form, both irons are present in a +3 oxidation state. In reduced form, one iron is present in +3 and another iron is present in +2. Okay, so if we see the sorry, here I made a mistake. This is not correct, because these are tetrahedral complexes, not octahedral complexes. So this is but this is for this is E, this is T2. 1 2 3 4 5. For this 1 2 3 4 5 6. So it's same, it's a EPG is symmetric, so we'll get less EQ. Here EPG is unsymmetric, here we'll get more EQ. Here EPG is unsymmetric, right? So now we have a D5. This is Fe plus 3 means D5. 1 2 3 4 5. So we have one more iron atom that is also having 5 electrons. 2 3 4 5. And here 1 2 3 4 5 6. 1 2 3 4 5. So in case of this one, these ferredoxins, they show anti-ferromagnetic coupling. Anti-ferromagnetic coupling, it's very important. So what is anti-ferromagnetic coupling? So two iron atoms are having a unpaired electrons. Now these unpaired electrons will get paired up. This will pair up with this, and this will pair up this, like that. All electrons gets paired up. Okay, so now the resulting S value is 0, spin is 0, because all electrons are paired here. Now we'll go for reduced form. In reduced form, one iron is in +3, another iron atom is +2. So this electron get paired, this get paired, like that, these two, and this one and this one. Now here this electron and here one electron that get paired, but this electron left as unpaired electron. So here is equals to 1/2. So this coupling is called anti-ferromagnetic coupling. So in oxidized form, S is 0 because all electrons are getting coupled. In reduced form, one odd electron is there, because of that S is off here. So now this is EPR inactive and this is EPR active. So oxidized form of 2Fe2 sulfur cluster is a EPR inactive, whereas reduced form of 2Fe2S reduced form of 2Fe2S unit is EPR active. And now we'll see the mass we can say that this is diamagnetic and this is paramagnetic. Okay, now if we see the EPR line, EPR spectra for this, here you will get less EQ, here you will get more EQ, sorry, mass bar spectra, because here it is a symmetric in nature, here it is unsymmetric in nature. So this is about the 2Fe2 sulfur unit. Next we have 4Fe4 sulfur unit. We have 4Fe4 sulfur unit. They are arranged in the cubic form: Fe sulfur, Fe sulfur, sulfur, Fe sulfur, Fe. So now this attached to sulfur, and further it attached to cysteine, sulfur, cysteine, sulfur, cysteine, and here is also sulfur, cysteine. So this is the structure for 4Fe4S unit. So here this is also present in two form: oxidized form and reduced form. So in oxidized form, 4Fe4S 2 plus, after taking one electron it will get converted to 4Fe4S 0. So in oxidized form, here we have two iron atoms in +2 and 2 iron atoms in +3, whereas in reduced form we have 3 iron atom in +2 and 1 iron atom in +3 oxidation state. Okay, So one electron transfer is taking place from oxidized form to reduced form. So in oxidized form we have two iron atoms in +2 and two iron atoms in +3, whereas in reduced form 3 iron atoms in +2, 1 iron atom is +3 oxidation state. Now we will see the magnetic behavior for oxidized form and reduced form. So now we'll take Fe2 means D6, 1 2 3 4 5 6. Likewise another Fe+2 also come here, D6. Now 2 Fe+3, 1 2 3 4 5, 1 2 3 4 5, and here we have 3 iron atoms in a +5 oxidation, +2 +2 6. 1 2 3 4 5 6. One iron atom is +3. 1 2 3 4 5. Okay. So now here also we will see antiparamagnetic coupling. So this is already coupled, we just neglect these two, and these two will get coupled, and these two, these two, these two. Okay. Now from we will come here, these two get coupled, these two get coupled, these two get coupled, and these two and these two. So resulting spin is here 0. In this case this already coupled, this coupled, this is also coupled, we just remove that. So these two get coupled, and these two, these two, these two. So now this one and this one get coupled, this one and this one, and this one and this one, this and this. So this electron is left. So here S equals to 1/2. So this is diamagnetic, this is paramagnetic. Oxidized form of 4Fe 4S system is a diamagnetic, and reduced form of 4Fe 4S system is a paramagnetic in nature. And this is the E pair inactive, this is E pair active. And if you see the mass bar spectra for this, here we will get less EQ and here we will get more EQ. So this is about the 4Fe and 4S system. We have next 3Fe 4S system. So the structure looks like this. Here iron, sulfur, here sulfur, so this is the structure. So in oxidized form and reduced form, this is the reaction 3Fe 4S 2 plus 3Fe 4S 0. One electron going and adding here. So in oxidized form 3 iron atoms are present in +3 oxidation state. In reduced form 1 iron atom is +2 and 2 iron atom is +3. Okay, now we will see the magnetic behavior. 1 2 3 4. So now we have 1 2 3 4 5, 1 2 3 4 5, 2 3 4 5. So here also we see the antiparamagnetic coupling like this, and now these two get coupled and these two get coupled, so this will remain as such. So this is a paramagnetic in nature. Okay, then E pair active also. And now we'll go for this red digit form. One, two, three, four, five, 6. 2, 3, 4, 5. 1, 2, 3, 4, 5. So here also we have a anti-ferromagnetic coupling, and this is already coupled. These two get coupled and these two get coupled. So here final S is 0. So this is diamagnetic in nature. So this is about the iron sulfur protein. I hope everything is clear. Thank you.